This is a short presentation on animal nutrient requirements. I'm going to focus on energy requirements. We've just finished on diet selection, basically diet, nutrition, and next we're going to look at what nutrition plants provide to animals. So at this point you need to just understand animal demand. The notes for this presentation are online, so if you follow along you can fill in the blanks, and the presentation follows pretty closely with the notes. Okay, the first thing to remember is that energy and nutrients are used in the animal to accomplish a lot of goals. First is maintenance, and I'll talk about all of these separately. Maintenance, and then above maintenance would be growth, lactation or milk production associated with gestation, and then finally activities related to reproduction. And all of these major activities of the animal are influenced by the environmental conditions and the level of activity of the animal. Let's start with maintenance then. Okay, if you've taken a nutrition class, you probably remember that maintenance is defined as basal metabolism plus some minimum movement and some foraging. That would be the definition of maintenance. Basal metabolism, remember, is the amount of energy required for a sleeping animal, and so it's just that energy required for things like breathing and respiration and blood circulation. So it's that very basic requirements to just keep the body going. And if you add that to some minimum movement and some foraging activities, that would be maintenance requirements. On a yearly basis, this is the greatest amount of energy that is needed by the animal. Just staying alive is the biggest proportion of energy needed by the animal. This is influenced by a few things. Size, for example. Larger animals actually have a lower basal metabolic rate as a percentage of their body weight than smaller animals. So, for example, a cow or an elephant has a lower basal metabolic rate and therefore a lower amount of energy that goes to maintenance or to basal metabolism than smaller animals like dik-diks and deer and sheep. So those smaller ruminants actually have more energy requirement for their size than larger animals. Young animals also have higher metabolic rates and higher energy demands than older animals. It's pretty significant. At birth, of course, it's the highest, and I've got some examples here. 132 kilograms per meter squared of body. At 15 weeks, 3 months or so later, it's half of that, 68 kilocalories per meter cubed of body, so cubic square meter of body size. And then 6 years, when animals fully grown, it's decreased again, so that's 52 kilocalories per meter cubed. And we often think about this in humans. We talk about when you turn 40, your basal metabolic rate goes down, or you turn 50, you turn 60, and it's harder to stay in shape, and it's harder to keep your weight down. Now, a lot of you won't have to worry about that, but I guarantee you when you hit 40 or 50, that your basal metabolic rate will go down throughout your whole body, and it will be harder and harder to keep off excess weight. Another interesting thing is that the type of animal, even the breed of animal, can make a difference. But on range animals, probably the biggest difference is domestic animals having a larger requirement for energy than native animals. Another interesting thing about wildlife species is they actually do lower their basal metabolic rate in the winter. And of course, that's a long-term evolutionary response to low requirements in the winter. With domestic animals, we've often removed those requirements of surviving the winter, so animals don't lower their basal metabolic rate so much in the winter. That is, domestic animals don't lower it so much as the wild animals. Another big requirement is just growth. Again, as animals get older, they're growing less, so they have less of an energy demand. With terms of rangeland animals, thinking about that just that last third of trimester of a gestating female is pretty important. The requirements can go up 10 to 15%. That'd be requirements for protein and energy. And it's interesting that 75% of the growth of the fetus happens in that last trimester. So we always talk about that last trimester as being important. Then right after that last trimester, a female, when she enters lactation, when the calf is, or the young is born and the animal enters lactation, and that is a huge energy demand. It kind of depends on what source you go to. It can be up to 45% greater than the needs for maintenance. In other animals, it might be less if they don't have such a high lactation potential. But conservatively, it's at least a quarter to a half more energy required after the animal is lactating. And then finally, reproduction. Just the activity related to reproduction during the breeding season for males and females, and then again, that last trimester of pregnancy where energy requirements increase for females. Like I said, all of these requirements are responses to the animal type or the animal age, but then the environmental conditions can also make a big difference. If you've ever fed cows in the winter, you'll know that if you get a really cold spell, animals will eat a lot that day when it's really cold, or the day after that, and that's because it just requires a whole lot more energy to keep the body warm, so the animal's energy demands are way up. The same is true in hot temperatures. It requires more energy for perspiration and more water, but oftentimes high temperatures also suppress appetite, so we don't often see the increased intake, but we do have an increased energy need. The level of activity is also really important. What is the animal doing and how much energy are they using? For example, it takes 15% greater energy for standing compared to laying. So just the act of standing up requires more energy. You might take this into account when you're thinking about sitting instead of standing up or walking somewhere. It's just that a much greater level of activity for just standing. And then animals that are like stall fed or not allowed to move around, that could be 40 to 46% less energy than animals that are out ranging. So the activity of going out and grazing actually requires quite a lot of energy. And this would explain why when we're feeding animals to get them to a slaughter weight, they're often fed in feedlot. It's convenient because the feed is there, but also feedlot operators don't want animals walking around a lot because it requires energy. So feedlots are confinement operations partly to reduce the need for energy. So based on all of these ideas, if you were trying to watch your weight, which some of you may be, what would you do? What kinds of activities or conditions might you undergo to try to lose weight? Think about that for a second. Okay, it's pretty simple. Of course, the first thing that has a lot of energy demand is lactating. Of course, that's not very easy to accomplish, and it's really not going to affect many of you. But it does explain why new mothers often lose weight right after they have their child, and certainly it explains why cows often lose weight right after they calve. Exercising, we know that exercise is good, but just think about the extra energy required for standing over sitting or laying, and then add walking upstairs as opposed to taking an elevator. Running, walking, swimming, working, anything that requires energy will help you use the energy that you intake, and it will help use energy or burn fat off the body. Then finally, one we don't think of very often, but because a cold temperature or a hot temperature really requires energy, keeping your house or apartment cold, or maybe doing more things outside. Don't hesitate to walk somewhere instead of heating up your car, because anytime that you're cold, that will require more energy to just keep your body warm, and you'll be using calories to keep your body warm instead of putting them into fat. So those are just a couple things you can think about. Tell me if you got some more that relate to these concepts of energy demand. Okay, now we're going to switch gears a little bit, and we're going to think about how those demands change over the year. I'm going to use an example of a pregnant female range herbivore. So, these data are based mostly on cows, but it's the same for sheep or elk or deer or pretty much any animal out there ranging on the land. So on the y-axis we have just kind of a rough number of energy and nutrient demand, and then how that changes from winter, spring, summer, fall, assuming that that birth happens about in spring. So as you're coming through the winter, the animal is basically at maintenance. And then remember, there's an increase in energy and nutrient demands in that last trimester as the fetus is growing. That's putting more energy demand on the female. But you have a huge spike right when the animal goes through birth and when the young are born and partition happens. Then lactation kicks in a big way, and there's a demand by the young animal, and that is taking energy from the mother, who is taking most of her energy from her body or from what she grazes to put into lactation. Okay, depending on the animal, that's going to slope off either fairly quickly or fairly slowly. But there is a big dip in the energy demand for lactation right at weaning. So you see that at summer. I've got it here. So on a classic range operation, we would remove all the calves sometime late in the summer, and then we'd see energy demand from the cow just go way down quite quickly. With wildlife, it happens over a longer time period, that weaning period, and it depends on the species, but all animals will go through that weaning period sometime late in the fall. And then an animal gets down to a level that is just that basic maintenance, that basic walking, digestion, breathing. That would be what we call maintenance level. And that will happen through most of the fall and the winter. And then again, once we come around the winter, we're at that first trimester. So just take a look at how much energy demands can vary over the year with huge spike in lactation. So knowing that that's occurring throughout the year, what can you do as a manager, whether you're managing wildlife or livestock, to help animals deal with that huge variation in energy and nutrient demand? Well, there's a few things that can happen. The first and most important idea is to really just get the timing right. Try to find a way when you know where the time of the greatest energy demand is, and try to find a way to make that coincide with the greatest nutrient supply. Okay, that depends on the type of forage, of course. Green forage, making sure that an animal is lactating and having young right as the new green forage comes on is important. But even winter forage can be very important, making sure that when that animal's in that maintenance, you have sort of a mainstay of winter forage. You could consider the type of operation you have. That huge flux due to lactation and partition in a cow-calf operation can be hard to manage, whereas if you think about moving towards a stocker-steer operation, you have to deal with growth throughout the season, but you don't have to deal with that huge fluctuation due to lactation. The idea of keeping animals moving up following the green up the mountain, that's an old historic grazing pattern called seasonal suitability grazing. It's used a lot in sheep operations in the Intermountain West, where animals spend the winter down in the salt desert, and they move up to the benchlands, say around Boise or Weiser, and then they move up to the highlands, say McCall or any of the mountains around those basins. So they're basically following green all the way, and that's a way to help the forage supply meet the demand of the animals. And then, of course, this idea of seasonal suitability is something that native animals just do naturally. They have their young in the spring when the forage quality is really high, and then their young wean off throughout the summer, and then by the time they hit winter, the young are weaned and they're fairly well grown. So those are all ways to coincide the demand and the supply. There's a few other things to think about. Another way to meet energy demand, especially in the winter, is to stock conservatively. If you have a lower stocking rate or a fewer number of animals per pasture, that allows for a greater amount of forage per animal, so that each animal selects the most nutritious food available. It's like a smorgasbord. If there weren't very many people in the restaurant, you would get to choose whatever you want. And animals are really good at choosing the best quality forage. So if you don't have very many cows in the pasture, that makes it so the animal can have higher nutrient supply in their food, so they have a more nutritious diet. Also, they have maximum selectivity, and they don't have to spend so much time looking for it. So it reduces the energy required to just find a diet, to just eat. And remember that energy required for walking around the pasture can be pretty significant, especially if you talk about some of the topographical issues we have in Idaho and the Intermountain West. That can require a whole lot of energy. So stocking conservatively has these two advantages that reduce that help the animal meet their demand. One, they get to choose the best forage, and two, they don't have to go very far to get it. Other things to think about. These are more sort of on the management side. You could introduce pastures that really provide the highest quality during a particular season. I know a lot of people don't like crested wheatgrass because it isn't a very high quality forage when it's mature, but it's a great forage when it's young. And so in the spring, young crested wheatgrass can have really high quality, and it's also quite good in the fall. And it holds its nutrients through the winter. There's also been quite a bit of work recently about how to keep the the range grazable throughout the winter and meet those maintenance requirements, and they're looking at using ryegrasses. This is work that came out of Logan, Utah, where they do some forages research. So they've got these new ryegrass varieties that hold their protein really well through the winter. The animal can meet that demand. And then also these grasses, they stick up above the snow, and they sort of act like tents or black bodies, they call them, to let the snow melt around, and you have an early spring green up. So those are some ideas about how we meet that energy demand even in the winter. I realize that it's low in the winter, but it's still significant, and the forage demand isn't able to meet, the forage supply is not able to meet those winter demands. Another idea is to plant shrubs. A lot of times we focus on grass because grass is important forage, but shrubs are really important, especially in the winter, for protein and phosphorus and vitamin A. The benches around Logan, Utah, there's been quite a bit of research where they use cattle to reduce the grass biomass, and this allows shrubs to grow. And the shrubs are needed by deer, of course, in the winter, but also can be used by goats and sheep and cows even. So that's just some research that we talked about in class before out of Logan, Utah. But planting a diversity of forages so that you have something that is coming nutritious throughout the whole season. So it might be shrubs in the winter, and then you might have an early season grass, such as even cheatgrass or crested wheatgrass, and then you might go to native range where plants are starting to mature in June or July, and then in the summer doing things like making sure that animals have an adequate forage supply, and going into winter making sure again that you have plenty of tall grass, which provides energy, and shrubs. So the key is diversity. There's no one forage that's a perfect one all the time, but there's a variety of forages that can be used throughout the season. Animals do have some natural ways to deal with that low forage quality in the winter, that time of low forage availability. One, of course, they can build up fat when forage quality is high. Certainly wildlife do this. Fat is a really important source for energy, of course, but also vitamin A is stored in the fat, so that's another important element that gets animals through the winter. There were some studies done on where they fasted animals, and they found that grazing animals, cows, sheep, deer, they can survive on fat reserves alone. If they go into the winter in very good condition, they can survive on those resources for half month to a month, so 30 to 60 days, and that they can do that without really any food consumption. Especially wildlife are good at this. They can last several months without starving, even without eating, if they go into the winter with good fat supplies. Remember, another thing about native animals is that they have the ability to lower the basic metabolic rate in the winter, and again, that's a consequence of low energy supply, and it offers low energy requirements throughout that winter. Some wildlife especially also have the ability to really carefully recycle nitrogen. Nitrogen is something that's also low in the winter. And it's interesting, some animals like bison, they actually take nitrogen out of their lower digestive tract, and then they recycle it through saliva so that it gets right back into the digestive system for absorption instead of just being lost in urine. Most other animals, most cows and domestic animals don't have this recycling skill, but native animals have evolved and maintained this. Of course, one thing we see in the winter often, especially in wildlife, is soil ingestion. And so animals will do this licking, they'll have licking sites, and that can be a pretty important way that animals meet mineral supplies. Of course, it could be just a kind of a boredom, or animals are feeling deficient in something and they're trying to fill that. Oftentimes the nutrients in soil aren't extremely available, but it can be important at some times. The classic thing that we do in range management or range livestock management is we supplement animals. It's a huge operational expense. I will post an article called Matching the Cow and Forage Resource. It's all about how to get that timing right so that you can reduce the need for supplementation, but it's often unavoidable. So I'm going to separate this discussion into 2 points. One is supplementing energy, and the second we'll talk about protein. One thing about energy, it's rarely economical to supplement energy in a range livestock operation. When it's supplemented, the use of range forage usually goes down. So the only time it really makes a lot of sense to supplement energy is if there is no range vegetation. There's too much snow, or you're just in a situation where you can't use the range forage. And in those cases, people can use high quality energy such as grains. This is often impractical, but it is used at times, like at heavy snow or in drought. It can also be used to just help young animals. They call that creep feeding, where the young calves and lambs can go into an area that the mature animals are restricted from, and then the young animals can use this higher energy, and that can be useful up to 6 months of age or so to really help animals meet those energy demands. So that would be an example of using grains. More often than not, we use straw and hay and anything that's kind of a fiber-oriented low energy supply. We haven't talked a lot about it, but fiber, those cell walls in plants, grasses mostly, are really basically an energy source. Remember, hay and straw has a lot of stems in it, and those stems are made of cellulose, and cellulose is broken down into energy in the rumen, made into VFAs, and that's used for energy. So cellulose is the energy source. It's the most common energy source used on range, and that's the one that we find in hay and straw. It's often more economical to use protein to increase the nitrogen supply. Protein is just, an amalgamation of nitrogen compounds. The reason that's useful is because protein is needed by the animal and not in good supply in the vegetation. One of the most economical ways to provide nitrogen is through non-protein nitrogen sources such as urea or biuret. They're really low-cost nitrogen forms. They are not true protein, but when they enter the rumen microbes can convert them into true protein, into protein. They use the nitrogen, it turns into microbial bodies, which becomes protein to the animal when those microbial bodies are digested. It can meet about 1/3 of the total protein requirement for animals. We often use, on range situations, we often inject urea or biuret into large hay bales. So when you see people feeding hay bales out on the range, oftentimes that already has that non-protein nitrogen in it, or maybe it should be suggested. Especially in the south, I see a lot of people using high protein feeds like cottonseed meal, alfalfa, soybean meal. Not used as often in the north here, although we do remember the Idaho has a lot of peas and lentils and split peas, so those can become really important protein sources. So those are high protein feeds. They do require that you use a feeder and find some way to give those to animals in kind of a measured source. Again, those protein supplementations are really important because the range forage often falls below 6%. And if it's below 6%, the rumen microbial growth is inhibited, and then animals aren't able to use the carbohydrates that are out on the range. So it's really important to keep the intake at least 6% of the diet protein in the diet of animals, of ruminants, because if they have that 6%, then the rumen microbial population will be fairly healthy, and that will allow animals to digest the cellulose, the standing grass that provides energy. So there's a real interaction between the amount of protein and the amount of available energy, and that's why most often we assume that there is enough standing dead grass out there and it can be accessed with protein, and the only time we start to supplement energy is if we don't have that standing dead biomass. So that's the topic for today. I hope that gave you an idea of how energy and nutrient demands change over time and how we meet the needs in the winter and how we can supplement animals or use timing to accomplish meeting the energy demand throughout the year. Talk to you in class.